thanks for watching, and let's practice a little bit with the coordinate method. And in particular, let's solve AUX plus BUY plus CU equals 0. So, first thing, we need to find our coordinates. So step 1, coordinates. And there are many choices of those. A natural selection would be to start with the vector AB. So Z would be AX plus BY. So you see AB dotted with XY, and W being some vector perpendicular to AB, for instance, minus BA. And so we get minus BX plus AY. But again, there are many other choices possible here. And the next step is to write UX and UY in terms of Z and W. Okay, so let's do that. So step 2. So by the chain rule, UX is partial U over partial X, which now becomes partial U over partial Z over partial Z, partial Z over partial X plus partial U over partial W over partial X. And that becomes UZ. So ZX is AX plus BY with respect to X, and then plus UW, and then minus BX plus AY with respect to X, and then what we end up getting is AUZ, and I believe minus BUW. It's like BMW, but with U. Okay, so now let's do the same spiel with UY. So UY, that's partial U over partial Y, and once again, that's partial U over partial Z over partial Y, and then plus partial U over partial W over partial Y. And what this becomes, so that's UZ, so ZY, so it's AX plus BY with respect to Y, so B, so that's all the buzz, BUZ, and then UW, and then WY, it's A, so plus AUW. And so we have those two things, and we just need to plug it into the PDE. And once again, to recap, here are Z and W, and we wrote UX and UY in terms of UZ and UW. And now the last step is to plug into the PDE. So remember, we have A UX plus B UY plus CU equals 0. So A, now we can substitute. So AUZ minus BUW, and then plus B, BUZ plus AUW, and again plus CU equals 0. And then what we end up getting is A squared UZ minus AB UW plus B squared UZ plus AB UW plus CU equals 0. And now comes the most satisfying part of today. We can cancel the UW term, and then in the end what we end up getting is A squared plus B squared UZ equals, if you want, or plus CU equals 0, and therefore we get a quite simple ODE really for UZ. So UZ becomes minus c over a squared plus b squared u. And now let's just solve this ODE. So now the last step is to solve this. So I believe step 4. So solve this ODE. UZ is minus c over a squared plus b squared u. And by the way, I do want to mention, if a squared plus b squared is 0, then both a and b are 0, and the PDE isn't very interesting. So it's kind of okay to divide here by a squared plus b squared. But most importantly, notice this is sort of the form y prime equals ay, where y is ce to the at. And so similarly here, u would be, so c, which means constant with respect to z, so a function of w, and then e to the, in this case a is this big constant, minus c over a squared plus b squared. And the analog of t here is z. And so summa summarum, in the end, we do get our formula. So what is u of xy? It's f of w, so f of minus bx plus ay, and then e of minus c over a squared plus b squared, and then z is ax plus by. Which is very, very cool. So in other words, using coordinates, we simplified our PDE to the extent that we were able to solve it, and then we were able to solve for you. All right, I hope you liked this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.